In this lesson, we start talking about the functions of several variables. Specifically in this lesson, we talk about elementary things in that regard, and later we talk about other aspects of the functions of several variables. Let's see the simple case of a function or functions of two variables. Let me start with an example. Here we have a function. We can, as usual, we can use f, g, or any other letter to call the function. But here, instead of one variable, we have two variables. So x and y are two independent variables. So y is not a function of x. X and y are two independent variables. Suppose I define f of x and y as, say, x squared plus 3xy minus y squared. So this is an example of a function of two variables. Of course, any expression, roughly speaking, any expression containing x and y will be a function of two variables. So, of course, I can evaluate this at any point. So, for example, f of 2 and 1, meaning that if x is 2 and y is 1, we get a value. So if x is 2, so 2 squared, 3 times 2 times 1 minus 1 squared. So I just substitute 2 for x and 1 for y. So I come up with a value. That will be the evaluation of the function at the point 2, 1. So in this case, f of 2 and 1 equals 9. Another way to look at this function of two variables is, instead of f of x and y, I use a letter z. That's very common to show in this way. So z equals x squared plus 3xy minus y squared is a function of two variables. Like in Calc 1 or 2, we had, like, for instance, y equals f of x. Y was a function of x. But when we have two variables, two independent variables, like z is a function of x and y. Of course, if we have three variables, then I have a function in terms of three independent variables, x, y, z, and I can give a name here like w, or just keep it as f of x, y, and z, and usually it's given by an expression containing x, y, and z. So this is a function of one variable. This is a function of two variables. This is a function of three variables. Of course, we can keep going and have more variables. For now, let's focus on two variables. One of the things similar to what we had in the one variable case is the determination of the domain of a function. So the domain of a function of two variables. Roughly speaking, as you might remember from Calc 1, we find when the equation of a function or a function is given by an expression, we find the maximum set that that expression makes sense. We do the same thing here. For example, suppose I have a function f of x and y. This is equal to some formula, for example, 5 over 2xy. Find the domain. As you might remember, in the one variable case, we were saying that it consists of all the x's with such and such, satisfying something. Here, instead of saying just x's such and such, we have x and y. So the domain, like in this case, consists of all the x and y's such that I would suggest that you think about this. What condition or conditions we need to impose on x and y that this expression makes sense? So this consists of all the x, y's such that I suggest that you pause the video and try to come up with some condition. So this expression makes sense if the denominator is not 0. And denominator is not 0 if x is not different from 0 and y is different from 0. So the way that I can explain this or write it down mathematically is x is different from 0 and y is different from 0. So that's how I describe the domain of this function. Let me give another example. Let f of x and y be equal to radical of x squared plus y squared minus 9. Find the domain. So I want to find a description that includes all the x, y's that make sense to this expression. You know that here we try to avoid negative under the radical. So this should give you an idea that how we should find the domain. So in finding the domain, I should consider that x squared plus y squared minus 9 must be non-zero, meaning I'm sorry, non-negative. Let me repeat, x squared plus y squared minus 9 must be non-negative, meaning that it must be more than or equal to 0. So this means that if I add 9 to both sides, x squared plus y squared must be more than or equal to 9. So that's the condition that x and y should satisfy. So to write the domain, it consists of all the points x, y, such that x squared plus y squared is more than or equal to 9. So for example, 0.14, is it in the domain or no? Let's see. 1 squared plus 4 squared. 1 squared plus 4 squared is 17, is more than or equal to 9. It's good. So this is in the domain. So 1, 4 is in the domain. But how about 2 and 1? 2 squared plus 1 squared equals 5. Is it more than or equal to 9? Obviously, it is not. So this is not, 0.21 is not in the domain. So this is the domain of this function. Try the next example on your own. Let f of x, the two variable function, f of x and y, be radical 75 minus 3x squared minus 3y squared. So I want to find the domain. So you may pause the video and try to find a condition that describes x and y's that give sense to this expression. Again, under the radical should be non-negative. Therefore, 75 minus 3x squared plus 3y squared must be, must be more than or equal to 0. So if I add 3x squared plus 3y squared to both sides, I will have 3x squared plus 3y squared is less than or equal 75. So I add 3x squared plus 3y squared to both sides, and then I switch the two sides. I wrote it this way. 70. So when I add 3x squared plus 3y squared to both sides, 75 is more than or equal to 3x squared plus 3y squared. In other words, 3x squared plus 3y squared is less than or equal 75. Here, obviously, I can factor 3 out and divide both sides by 3. So x squared plus y squared is less than or equal 25. So the domain consists of all the points in the plane such that x squared plus y squared is less than or equal 25. In the previous example, x squared plus y squared was more than or equal to something. Here it is less than or equal to some number. Another example. Let f of x and y be x cubed minus y cubed. Do we have any restriction in this case? There is no radical, no division. So every x and every y makes sense for this expression. So the domain is everywhere. So all the points in the plane, all the x's and all the y's, meaning that all the points in the plane, they can be the domain of this function. In this situation, D, in fact, is the entire plane, or we show it by R2. As you know, R is just the real line. R2 is the entire plane. So this R2 means all points in the XY plane. So sometimes the domain is everywhere. Let me give another example. Find the domain of g of x and y equals ln of this expression of x and y, ln of x squared minus 5y. So we should be careful that ln makes sense, or in general logarithms make sense for positives. So the only condition that we need to impose on this function is to the one that says that x squared minus 5y is positive. So the domain consists of x and y's such that x squared minus 5y is strictly more than 0. Equal to 0 doesn't make sense because ln of 0 is undefined. So here is strictly more than 0. For example, point 3, 2. Is it in the domain or not? 3, 2, 3 squared minus 5 times 2 is obviously negative 1. So it's not more than 0. So this is not in the domain. But point, say 4 and 3, that's in the domain because 4 squared minus 5 times 3 is positive 1, is strictly more than 0. So 0.43 is in the domain. Before the next example, let me remind you that, as you know, from courses like pre-calculus, when we talk about sine inverse, some of you would like to use arcsine for that, or cosine inverse, or arc cosine. These make sense if x is some number from -1 to 1. As you know, sine inverse or is inverse function of sine when we restrict the domain from -π/2 to π/2. But in any case, sine inverse is defined from -1 to 1. Because sine, when we define it from -π/2 to π/2, the range will be from -1 to 1. For sine inverse, the inverse function, the domain of sine inverse is the range of sine. That's why the domain is from -1 to 1. This is something that in pre-calculus you have seen this. Having this in mind, that sine inverse and cosine inverse makes sense when x is between -1 and 1. Let's do this example. Find the domain of, so here a cosine inverse is involved. Z, our function, I show it by Z, cosine inverse of 2x minus 3y. So what conditions are we supposed to impose on this function so it makes sense? So here I should make sure that 2x minus 3y is somewhere from -1 to 1. So it's very simple. The domain is all the xy's such that 2x minus 3y is more than or equal to -1, less than or equal to 1. This is just based on the that reminder on the top from pre-calculus.